on today? Say hi in the chats, either YouTube or Discord. Hey, DCD. I know you've told me when you're gone, but I have no idea. I don't remember it. Hey, Paul. Seems like you can see and hear me, so let's get started. Hello, everybody. My name is Scott, and I work on CircuitPython for Adafruit. I go by tannewt online. And if you don't know what those things are, well, tannewt's my username. Adafruit is the company that I work for. I'm a contractor for them, and they do open source hardware and software based out of New York City. I work remote, so I'm a contractor for them. So that means if you like this stream, you can support me by going to adafruit.com and purchasing hardware there. You say, oh, what do you mean by hardware? Well, I'll show you one thing that I'm getting pretty excited about, and let me hold it right side up. This is not a board designed by Adafruit, but the chip over here, actually. This one's called it's a microcontroller. It's a little tiny chip that has like everything you need to make up a computer. It's got like volatile and non-volatile memory. This one does a bunch of Bluetooth stuff too. This is from Nordic, the nRF54LM20, which is one of the new boards we're excited, or new chipsets we're excited about. So my job is to put CircuitPython on these things. So CircuitPython is a version of Python designed for these microcontrollers. And what they do is they present, if they have USB, they present you a CircuitPy drive where there's a code.py file, and it's a text file of Python code that is run completely standalone by that device. So you have the source code come along with you on your device, which is super cool paradigm. So I work on CircuitPython for Adafruit, and this is a deep dive. So I started doing these in the pandemic, so it's been a while, actually. So it's a chance for me to show off what I've been working on in the past week or so, or two if I've skipped a week, and also a chance for me to answer questions. So if folks have questions about CircuitPython, electronics, that sort of thing, microcontrollers, feel free to ask them in the chats. We have both the YouTube chat and the Discord chat. You can go to the URL adafru.it/discord to join that one. The nice thing about the Discord chat is that it lives longer than just the stream itself. So that's where we are during the week when I'm working on CircuitPython. I will not be around Monday through Wednesday because I am out, but I'll be back on Thursday in the chats, and then Friday I should be able to stream, assuming my two young children and myself are all healthy, and my wife is healthy too. So yeah, that's deep dive and the intro, and I want to talk about the LM20 like I showed, and Zephyr, because I'm getting back into Zephyr work, which I took a very long detour into hardware land and hardware in the loop testing, which I will fully get back to, but it's one of the main things Adafruit does is we create awesome dev boards for different chipsets, and then we sell those. So that's why I get paid. And I'm trying to find an Adafruit dev board. Here's an example. So here's an example of an Adafruit created dev board. So this is called the Feather system. So on top here we have the Feather Ada logger, and then there's a board underneath here that is a Feather nRF54LM20, and these boards stick together like this. So it's kind of a like standard form factor. This is called the Feather form factor. The like little microcontrollers under here, and this is a Bluetooth chip. So this is an older Nordic Bluetooth chip, and we'd love to make a new one of these with the LM20. I think we talked about last week why that's cool. I will definitely put a USB-C on the newer version, and like it's got double the CPU speed, double the RAM, and it's got high-speed USB and not just full speed. So lots of cool things that we can do with the newer chipsets, and so that's where I come in, is making sure that we have the software support, the CircuitPython support for new chipsets like the LM20. So usually where I start is on this dev kit thing. So this is like what you could buy today from Nordic. And I have my criticisms of this dev board design. Should I go into those? But usually what happens is that the manufacturers create dev boards and dev kits so that people can try new chipsets. So that's why it's a really great way. It's not only a great way to get a head start and access to a new chip, but it's also actually a really good indicator that the chip is actually like close to being available, because vendors will announce chips before you can even get them. And it's easy to get excited when you see an announced chip, but it's good to take it with a huge grain of salt until you're actually able to get them in your hand. So we've kind of like flagged the LM20 as like a cool chip that we want to support in CircuitPython, and we've chosen to do it with Zephyr. So I've talked about this maybe last week, but a lot previously before my big detour. Hi NetVentive, welcome. Zephyr is a real-time operating system that has kind of standard APIs for a lot of different things, and a lot of standard stacks for things. So like Bluetooth stack between the radio and like the high-level software that you would do. There's a whole lot of intermingling stuff, and like CircuitPython currently supports, I think, 3 different Bluetooth stacks, which is just a huge pain for us to maintain, because they're all like slightly different and have slightly different features. And so we have like 3 different versions of BLE.io between CircuitPython code and the Bluetooth stack. And Zephyr's gained a lot of momentum since we did that. And so by moving CircuitPython over to Zephyr, we hopefully, and when I'm working on Zephyr, it feels like this, I'm doing it the last time. So when I get BLE.io going, this is the last time I've got to do like these parts of BLE.io, and I can spend my new time or my subsequent time adding more CircuitPython APIs that expose new features. Hi, Raul from Peru. Thanks for saying hi in the chat. So what would that mean, for example? So another nice thing about Zephyr is that the Nordic works on Zephyr for their chipsets, and they're like key players in the Bluetooth spec. So when new features come to Bluetooth, usually those features have already been implemented in Zephyr, kind of in their prototyping phase. And so it's really, I think, going to be a nice thing for us to be like, oh yeah, we like Bluetooth 6, BLE 6 came out, and we can do the things that, like we don't need to worry about the stack side of doing all the new features, because Zephyr should get those new features as well. So things I'm excited about once we get all the existing BLE.io functionality in Zephyr is that we can also do things. There's 2 features that are kind of on my mind. One is LE audio. So I'd love to get to the point where you can use a pair of Bluetooth headphones with a CircuitPython device. Or the opposite. The opposite would be true too, of like using your CircuitPython device as a Bluetooth speaker, right? So like being able to take in audio and pipe it into our ever improving audio pipeline stuff that we've got in CircuitPython. So being able to do Bluetooth audio. Now there's 2 types of Bluetooth audio. There's LE audio, which is new and like not well supported in like terms of products. And then there's the old school Bluetooth classic audio that just like really, I think, got Bluetooth on the map, but it means that like a lot of legacy devices still support it. So I would love to get us to the point where we could do Bluetooth audio in both the classic and the LE sense. So that's something exciting and something on my radar. And then doing it in both directions of like being able to do synth.io and CircuitPython and listening on your headphones, and also playing from your car or your phone to CircuitPython, which would be cool too. And then the other thing that's on my mind is it's called channel sounding. It's a feature of BLE that they added in 6 that is trying to do distance measurements using Bluetooth in a secure way. So when I'm ranging my phone to a CircuitPython device or a CircuitPython device to another CircuitPython device, There's no other things that can kind of like intercept that and throw me off. So yeah, where am I at now? Well, I've got a pending PR. Let me go to the desktop. A PR is a pull request. And so this is I've made these changes and I'd like to get them into mainline CircuitPython. And then once they're in mainline CircuitPython, they'll show up in the nightly builds, the absolute latest builds, plus like any pre-releases that we do. We kind of have two tracks of CircuitPython releases. We have stable releases, and those come from a branch. So they only get fixes that go to the branch, and then we have pre-releases that come from main. And then like the stable, minor stable release like 10.3 will come from main, and once we do that, we'll do a new branch for 10.3.x releases, for example. Any questions before I keep going? So I had started this work months ago, and then LLMs came along and changed the game, and they're still changing the game very much so. One of my insights that led me to go on this detour into hardware in the loop testing was actually this fact that like I could generate a lot of code, but actually testing it was hard. And so you'll see here that I reference the bsim. So one thing Nordic has done is in Zephyr, there's a way to emulate Bluetooth devices completely on your like Linux computer, or on your host computer. I don't know. It might work on Windows too. I don't think it does, but yeah. So in our continuous integration tests and on my computer, I could just run bsim tests to test BLE basics, which is awesome. I did do a little bit of testing on the device itself, and I did find a couple other issues because I was testing against my phone, and my phone was like, this is weird. So it's still good to do manual testing, although now that I say that, I know you can actually take run an Android emulator and connect it to the same like Bluetooth environment as bsim, which would be cool too. So where are we at? Well, when I was working on this before, I had added Zephyr BLE support for advertising and scanning. So this is the like first step of Bluetooth low energy, where you're just saying like, hey, here I am, hey, here I am, or listening for those broadcasts. And then there's cool stuff that you can do with that. Like I did a demo ages ago when I was doing this kind of originally, and you could say like, hey, I'm this color, no, and then another one would say I'm that color, and as you move the third one, it would like try to like know which one it is. Now that I'm talking about that, there'd be a cool channel sounding demo where you could have two and use channel sounding to do a better measurement between the two. Yeah, so advertising and scanning is like the first stage of BLE. And then the second stage is like going up from kind of ephemeral messages where you're just blasting them out to a secure connection between two devices. And so there's a process for you to say like in an advertisement, hey, somebody connect to me, or yeah, somebody can connect to me, or you can listen for those messages and initiate connections. And that's the terms you get are like central and peripheral. The central is one that sees an advertisement that says you can connect to me and initiates it. And peripheral is the opposite end of that connection. So I had that working as well. And now this PR is adding what happens after you're connected. So there's a separate system once you have a connection called GATT. I forget what it's called, what it means. I think of as attributes. But each device on that connection can have services that it serves up. For example, device information or battery level. So if it's a battery-powered device, it can have a battery info service, I think is what it's called. And so it could say like, hey, like one of the services I have is like this way to see what my battery level is. And that service is made up of characteristics, which are like I think of them as properties on a CircuitPython class. So you want to read the battery level while you're talking to like this object that is the battery service, and there's a level property on it. And then there's two roles to that. So either side, generic attribute profile. I'm not sure that's true, because there's also gap. Gap is the process for connecting. Really gap. Punch through. Gap is generic access profile, and GATT is generic attribute profile. Okay, you're right. I don't know why they're profiles. I think the notion of profiles is inherited from Bluetooth, not LE. But yeah, so like gap is device discovery and connection. So that first part I talked about, and then GATT is like how attributes are transferred. Yes, I appreciate you qualifying it, and it was right in this instance. Okay, so so I had the gap side of things working, and now I wanted to get GATT working. So GATT is this process of saying, I want to serve this service, or I want to talk to this service. And so this PR that I opened 2 days ago is a bunch of changes. I say straight here that like I'm using DeepSeek V4 Pro to do the code generation, but I prompted it, and I'm using bsim tests, and I like did a lot of like reprompting to get the bsim tests using the Adafruit BLE library, because Adafruit BLE library does this kind of weird abstraction that throws people off. Most of GATT has similar profiles in ANT+, which predates BLE. Implementation is different, mostly in verbiage. Yeah, I think one of the challenges, thanks Lanyu, for one of the challenges of BLE is that they have a lot of terminology, and only after you've like really learned it does it make sense. One of the main examples I think of is so there's this notion of like a central and a peripheral, and that's describing the gap process of who's initiating the connection, basically. The central initiates the connection to the peripheral. But then there's also this notion of client and server, and that's a GATT term. So that's the like either device on that connection can have servers and be a client of the other's servers. And then there's services, which are like the definitions of the structure of the servers. Yeah, I think we did do the reason I pulled up Learn is because there is a like, we did do a BLE thing. Oh man. I know K-Town did it originally. It might just be called BLE Basics. That it covers this terminology. LE connects. Intro to Bluetooth Low Energy might do it. Or this might be even older. GAP and GATT. There are similar terms in CAN Open DeviceNet. Oh, I've not done CAN Open or DeviceNet. It might be really CircuitPython. It's not that one. I don't remember what it's called. Getting started with CircuitPython and Bluetooth Low Energy. Bluetooth Low Energy Basics. Yeah, here we go. This is what I was thinking of. Central and peripheral, advertising and serving. I thought it was going to be scanning. But this is the basics of using CircuitPython for it. So we have this Adafruit BLE library, and we have this notion of being able to import a service. So you could say UART service, and then that makes it automatically makes it available to anyone that you're connected to. And you can also advertise that if somebody wants to connect to it, you can do that. So this is actually what I was testing with the LM20. I don't have it currently flashed on there, so I'm not going to show you. But we could talk about the next thing that I'm working on. Any questions about that? So this includes, there's a couple tricks about BLE attributes. So the idea is that it's the state that you can just read, but in practice, there's ways of like making it not that, where you actually want like a stream of things. So like in that example here, you're a UART, so you're doing kind of serial back and forth, and you're not really like, you need some buffering. So like one device is going to write to a characteristic a series of characters, and like you don't just want to overwrite the value and only read the last value. You want smarter smarts of like, when the other device, when the client device writes to this, I don't actually just want to store the value that they wrote, but I want to store the history of the value, right? I actually want a buffer. And so there's characteristic buffer that does that. So it just throws the contents of all packets into a ring buffer, and then CircuitPython can read those as you get them in. So I implemented that for UART. And then there's additional things. I think it's HID that we needed it, where not only do you need to store all of the things that were written, but you actually also need to keep the packet delineations the same. You can't just put them into a ring buffer. You actually need to know the order of the packets. So I think HID is that way because there are multiple byte like copies of the HID reports, blah, blah, blah. So those should be in there too, in this GATT update. What is next then? So the next thing on my radar is bonding, pairing and bonding. So once you are connected between two devices, you may actually want to kind of upgrade your connection from an insecure one to a secure one. And the process of doing that is called pairing. There's a lot of different ways to do pairing. You may have seen things like typing in 6-digit codes and stuff like that. But the way that we only support one way in CircuitPython, which is basically you just do it. And you don't have to confirm codes or anything, because we didn't know that you would actually have any sort of like way of displaying codes to confirm. And so in CircuitPython, we just do, I think it's called like simple pairing or something. And so that's what I have pending branch worth of changes for. This has been my setup for figuring it out. So up here, I'm running the BSIM tests. Over here, I've got my LLM clanker helping me fix those tests. Over here, I've got a TO to the board I'm working on. This is like CircuitPython itself. It's actually got, right now, it's got an example that's doing GATT stuff, so I need to update the example here. And then we also have the debug UART output. So this is like the behind the scenes debug stuff from Zephyr that we're all looking at. So I will use this button, the enlarge or maximize button, to kind of get us to the point where we're only seeing one of those. And I've got about 30 minutes, so I can do my bonding testing. The reason that the GATT stuff's not working is that because it is GAP and not GATT, I can actually concurrently work on these things. So it might take a couple weeks because I'm going to be out some next week and Dan's going to be out some as well. But now I can decouple these two changes change threads between the GATT stuff and the pairing and bonding. I haven't said what bonding is. So pairing is this process of going from an insecure connection to a secure one. There's some cryptographic keys that get exchanged in order to do that. And bonding is this kind of like, hey, not only are we going to pair, but we're going to remember the things that we came up with. So we're going to, I think it initiate, you save, once you're secure, you come up with new keys that you share to each other that you keep long term. And then like every time you connect, I think you derive your like secure connection keys based on that shared info, I think is how it works. I'm not a security person, but yeah, so bonding gives you the ability to go straight to a secure connection without having any user involvement. It's really good if you need to reconnect. So like, oh, I dropped off. I walked over to the like water fountain, and now I've come back, and my devices need to reconnect to each other. Bonding allows you to do that like all the way to secure again. And in fact, bonding allows you to obscure your identity so that like when you're advertising, you can look like some random device, but to something you've bonded to before, it can actually say like, oh, so-and-so's back, which is interesting. There's like Dan's working on BLE workflow stuff, and the way that BLE workflow does it is that like if it's bonded, it advertises kind of like in this anonymous mode of like only things that have been bonded to me will know, and they should auto connect back to me. Whereas like if you're not in that mode, it will just like publicly broadcast. Anyway, so let's take a look at this. So I've actually prompted, say, hey, like the old tests don't work anymore. Fix them. So the update Zephyr commit, change the BT initialization flow. So this is like, I did a first draft LLM, like, hey, make bonding work, pairing and bonding work. And now it's like, hey, like you broke these tests, these BSIM tests that were working before. And now it says it has some fixes to it. So let's just go over to our test pane and just try it again. So we're going to make sim. And the GATT PR also adds BSIM support for the nRF54LM20, which is the one we're particularly interested in, which allows us to run our BSIM tests in a like fake nRF5340 and an nRF54LM20. Welcome to Deep Dive. This is the weeds. This is the weeds, but Bluetooth is super cool when you get it working. And I spent a lot of time, and we spent a lot of time on BLE workflow with the idea that we could, a lot of what I think about is the workflow for CircuitPython. So like, how do you access the code and the drive and the files and get the serial response back? So now I can do pytest. And one of them that I really wanted to do for a while was what I call the BLE workflow, which was I have a phone or a laptop and I want to connect wirelessly to my CircuitPython device. And BLE is a great way to do that. And it never really took off. It's rotted enough that Dan's trying to fix it. Whereas we did after that as a web workflow, and that's caught on more. But web is like, you generally need another AP. So yeah, I'm excited to get BLE workflow good. The reason I don't think it took off originally is because we spent a lot of time on phone apps, and then the phone apps just never really took off. And I think the phone apps never took off because it's such a pain to code from your phone. Like typing text and editing text is like really terrible on a touchscreen. And so I think what we need to do is, what I'm very excited to do is I want to do a new app that uses an LLM to generate CircuitPython code, because I've used LLMs to generate CircuitPython, and they're quite good. So having a phone app that can do an LLM locally or remotely, say, I want a CircuitPython thing that changes my blink thing, and you can do the editing over the Bluetooth workflow, I think would be super duper cool. LonU2 says, Connection is where I have failed to make BLE work, and I'm thinking where most people have issues and why hasn't worked well for others. Okay, so we passed most of the tests, and let's just do, what I've been doing is I do clear. Bonding, like bonding, pairing and bonding is tricky. Because when you're testing it, like if the device loses its bonding state, but your phone still has the old state, you actually have to go into the settings of your phone to like clear the bonding state. If you're doing it from your laptop, usually that bonding state is actually stored in like your BLE or like Wi-Fi combo chip. It's not even in like your OS necessarily. It's like, it's the device itself that has some of that state. So yeah, it can be tricky. Tricky. Okay, so here it's trying to run the BSIM test. So let me show the test. Pull up Z. And we are in, I'm starting to get my branches mixed up again. So CircuitPython ports, and this is one of my complaints about Z, and it's gotten better, but it does a lot of indexing when you open it, so it's like kind of slow if you don't just leave it open all the time. So port Zephyr tests, and then under BSIM, we can say BSIM pairing. Oh, yeah. So this is the way BSIM is set up. So the idea is that, let's skip that for now. So this is a pytest test, and you give it 2 CircuitPy drives. So what it will do is it will actually run, let's close this to give a little more space. So pytest is kind of weird, but you could say, okay, I want 2 CircuitPython devices, CircuitPython 1 and CircuitPython 2, and then those will be, those are like the nRF54LM20 BSIM builds. And then there's a third binary that you run that kind of connects the two. And so one is running with, this is, it's a dictionary of files to put on its flash. So it generates like a fat FS image and mounts that as flash. One has this peripheral code, one has the central code. You get these two, you wait until they're both finished. So they've joined the simulated BLE environment to each other, and they've tried to talk to each other, and now they're finished. One maybe crashed, and then you take the output from it and you make assertions about what you see in the output. And that's your test. So that's how you're able to pretend to test BLE without 2 actual devices. And the idea that I have generally is like when you find bugs where you haven't tested it, like you should always be able to reproduce it here. And this is something that we've always been very bad about in CircuitPython. MicroPython is actually quite good at their test coverage, but I've always punted on it because simulating devices is quite hard to do true simulation. One thing that moving to Zephyr gives us is not only does it have all this native sim stuff already, but it gives us this abstraction layer where we can, because we're targeting the Zephyr abstraction layer, we can implement the backside of that abstraction layer in a native sim capable way instead of in a like vendor specific way, and then we can kind of test ourselves against the Zephyr API rather than having to worry about the vendor's implementation. That is to say that like there is still a place for all this hardware in the loop work stuff that I've done, because you actually do want to also run the tests on real hardware, because you might actually find bugs either in implicit API contract stuff that wasn't right, or like straight up driver bugs in Zephyr land. So bsim is great, native sim is great, but it's not sufficient. But it's still a huge improvement. So this model of like, I have two CircuitPython devices, and one has this code.py and the other has this code.py, that has really informed a lot of the work that I've been starting to do where I was going with the hardware in the loop stuff, where I want to be able to say, in this file, now I want to run it, instead of running it on the bsim binaries, I want to run it on this device and this device, and those devices are remote devices in like the same room. And like, we can parameterize based on board ID a little bit, but the idea is that like, once you write a test in pytest like this, we should be able to run it in all sorts of different combinations of different boards, both native sim virtual ones and real ones. And they should all work in all places. So let's take a look at these CircuitPys. This CP to CP is actually passing. So what we can see it's doing, so these are generated. So one reason I know LLMs generate pretty good CircuitPython code is because that's what this is. So it's importing BLEIO, it's coming up with a name for the device and packing it into some advertisement. And then advertising, usually if you were doing this, you would use Adafruit BLE, the wrapper around underscore. That's why it's underscore BLEIO, is that we don't expect you to use this directly. We want to be able to change the BLE underscore BLEIO or dunder BLEIO, or it's not dunder. Anyway, this BLEIO module, we don't guarantee will stay the same across major versions. We want to be able to change it with the promise that we'll make the Adafruit BLE library the same. It will follow its own versioning. Okay, so the peripheral is saying, hey, I'm gonna like start advertising. You set a flag to say that it's connectable, and then we wait. This waits 12 seconds. It's just sleeping. And then if it's not connected by that point, so something, a central hasn't come along and connected to it, we print this and we sys exit 1, and of course, like, we're gonna make sure that the test will make sure that we've gotten to this print instead. And then we're also tracking if we're paired. We're waiting for the central to initiate that too, and then we'll disconnect. So that's what that test does. The opposite side of that on BLE side is like, okay, we're scanning. We're looking for something called pair perif, and it's connectable. Once we do that, we stop scanning. We connect with a timeout, and then we pair, and then we disconnect, and that's how things should go. And then this paired property code, this is one thing I had to do. Is like, I don't want it here. I actually want it here. I'm still figuring out like exactly where you want the CircuitPy code. So this uses the same peripheral code. This time it's using the slightly different central code. And it's checking the state of this paired property. Bond code, I think, is what we're failing. Verify bonds are saved to storage and survive disconnect and reset. So let's see what it does. It is saying, I'm a peripheral, advertise, pair, and then adapter is bonded to central. So this is saying, are we bonded? And then we wait to be disconnected, and then we make another, so then we start advertising again after we disconnect. We're connectable again, and this time we should be able to connect back. And then the storage stuff should get us all the way to being paired automatically. The central will find us, try to connect, try to pair and disconnect. And then bond. I forget. I thought we had a way to say, like, should we bond? I suspect that pair, if we look at the docs for BLEIO, I bet bonding is enabled by default. So that's on a connection object. Yeah, bonding is enabled by default. It's probably a little clearer to add it in this bsim test, but it's not working. And yeah, I just ran that one file. And that would do it. Adapter object has no attribute, is bonded to central. So this is a case where it's making stuff up. It's kind of a double-edged sword. So it's interesting the things that it makes up. Because actually, like, LLM's strength is to like kind of see a pattern and make an assumption based on that pattern. And so one of the first times I like saw like clearly LLM generated code on the support forum, the Adafruit support forum, was like, oh yeah, like that's what we would name the library, but we don't actually have that library. Like Adafruit _ CircuitPython _ like some chip name, right? And it's like, oh, this code should work. And it's like, well, like that's what we would name it if we had it, but we don't have it. And so I actually see like these LLM hallucinations about API as a like super interesting signal of like, should we have it? Which is interesting. So the question is like, is there actually a way for us to know whether we're bonded again? It would be good to do erase bonding. But I don't actually know how we could test that. What does Connection have? Connection might know bond must be true. Connection interval max packet length. We don't actually have a way of knowing that we're bonded, huh? I guess it doesn't matter. I don't actually know how we could test that. Oops. So what does the CircuitPython embedded code call to set the pair bond value? That keyword arg makes it down into common hal, BLEIO, connection, pairing? So I think pair status could tell us. Let's see if it actually Bonding is enabled globally via config BT bondable. Yeah, this code is what BLEIO calls it. The C side is common HAL BLEIO connection. Connection is the object. That's interesting that maybe bondable is just like in Zephyr, it's like you are or you aren't, which is fine. Drop the config part to be able to find the definition. Ooh, Bluetooth audio. So one thing that's important about pairing and bonding is that there are part of the definitions of characteristics can be that you can only access them under certain security environments. And so one example is like, there's an example I found about a device info service, so basically like a way to discover what you're connected to, and like that requires you to be like secure, have a secure connection to be able to do it. Another example is like iOS, I think, used to have a notification service that would allow a BLE device to get access to the notifications on the device. I think they've actually removed that in the latest version of iOS. But that was another example where you had to go through the pairing process to get access to it. I think HID is the same way, so you can't pretend to be a BLE keyboard unless you're in this upgraded secure state. Bluetooth audio. Bondable per connection. Okay, so let's take a look at this. Bluetooth host. So the host part of this directory is that Bluetooth stacks usually get split into two. They get split into a host stack and a controller stack, and there's an API between them called HCI, which is the host controller interface. And they can either be on the same chip or they could be on different chips or different cores. So the nRF54LM20 has the controller side on a separate core from the host side, but the nRF54LM20 has both in the same core. Let's see what it says. This option is the default value of the bonding flag for any ACL connection. If the option is true, the default bonding flag is true, or the default bonding flag is false. After a connection is established, the bonding flag of the connection can also be changed by calling its BT connectable set bondable if the configuration, the bonding flag per connection is enabled. So this is a way of bondable. So we're doing it from pair. Whew. So I think that that's what we would want. This is interesting. You can use a set of debug keys, so that like if you Wireshark it, you can still look into your like secure connection. We don't want BT bonding required. So now this is when I say, LLMs, they love to do it this way. So I was saying like, I said something like, hey, this doesn't work because this is missing, and it just went like, well, I could have that. The problem is I don't want it changing any of the BLEIO APIs. in the Beely workflow, do private advertising in the test and remove the Beely.io API change. Like we don't need to change Beely.io's API at all. Like that should not be something we do, because until we're doing like audio or channel sounding, like underscore Beely.io should stay fixed, because we have 3 other implementations, and let's not change that at all. I don't think we need to worry about the bonding thing. I think maybe what we do is we say, we could just raise an exception if you try to pair with bonding off. The private advertising thing is pretty cool. It does mean that you get like a bunch of spam on when you do BLE scans, because like other things that are watching it see a bunch of different, seemingly random advertisements instead. So we passed the test by changing the test case. Yeah, in this example, we're gonna change how the test is done, because it was using a non-existent API. This test was also just added. This native sim bsim tests did not exist for other implementations of Beely.io. So that's the other advantage of running on actual hardware would be, is we could actually run, I want to be able to run these pytests on other devices using other port implementations. But yeah, these tests are being added as Zephyr gets better. They're not from previous things. MicroPython has their own test running setup that we don't use. We do run MicroPython's Unix port-based tests for like testing the VM to make sure we don't regress the MicroPython VM. But we don't use, because we have our own hardware APIs, we don't use their like on-device tests really. So I'm doing it different with this pytest approach instead. Okay, so DeepSeek is working on that. I suspect that private advertising will not work, but I would like it to, so I'm okay with it. Yeah, so it says it's not implemented. It's like, okay, implement it. I think one thing that I'm, yeah, so it said, oh, I need to implement it. Which is fine. I want to implement it. And I need to get away from with the GATT stuff, I was a little like, oh, I should test this. Oh, I should test this. And it's like, wait, actually, like maybe just do more, be a little bit more aggressive. We want to get it out there so people can use it. Kobayashi Maru passed the test by changing the test. Not a valid way, Mr. LLM. I would believe that if the test if it wasn't a new test, but if it was an old test that we've been, this is the same way I feel about the underscore Beely.io API. It's like, this thing's been around a while, and we have a lot of examples based on it. We don't need it. So it's working on that. Isn't preserving static addresses. Yep, fix it. And this is like such a different way to working than how I would have before. but I feel like I really did get GATT. I got the GATT stuff, the packet buffer and the characteristic buffer stuff going way quicker. I did have to say, like, hey, like, isn't it supposed to be that when packet buffer is sending out, it does this behavior? And I was like, and once it did that, it was fine. And I fully expect to find more bugs, and that's another thing I've had to say, like, I just need to stub it out, and then we'll find the bugs as we get to them. So yeah, this is my life. I've been having kind of like, sometimes I do 2 threads like as I wait for this. One thing I could do that I was actually thinking I should do. So this is my LLM going. I actually just want to make sure that all of my boards build. So I can do make all, and it will build everything. And it does all 26 boards concurrently, but the 26 boards are sharing kind of CPU bandwidth. So like make has this notion of job server. So like how many jobs can you run concurrently? So this is running 26 in parallel, but they're sharing a job server so that like the number of my CPUs, it doesn't try to over allocate my CPUs. And it actually made the Zephyr builds quite a lot faster because there's a lot of single threadedness to the builds before it gets to the multi-threaded part. It's still kind of slow, but it's a quick way to just like test everything. So doing that while it's working on the bonding. The other nice thing about tests, I will say, is that it's actually a really readable way to know what works. Like if the tests pass, you can look at the test and be like, you cheated that test, or you could say like, oh no, I buy that it works, and then you can get to yourself into this like manual testing mode of like, I have to do this or that and make sure it works, and then you could say like, oh, it doesn't work, but now I need to add another test that fails, or change a test so that it fails, that sort of thing. Any final questions? We're just about out of time. I don't know, maybe I'll get pairing. I'm like quite excited about Zephyr, getting back to Zephyr. When I was talking with Phil and Labora about the LM20, they were like, does this work? Does that work? Does this work? And I was like, Zephyr, 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 Zephyr. Should mean that it just works. They just tried it on one of the Renesas chips. They are poking at a Scilabs chip. And then I was actually just poking the ESP32P4. So here is, I just got it kind of started working. This is the P4X, which is the new version of the P4 running Zephyr CircuitPython rather than ESP IDF CircuitPython. And I was talking with the person on the Espresso side that's working on Zephyr, and I was specifically asking about SMP support. So the P4 is 2 400 megahertz or 360 megahertz RISC-V cores, and in CircuitPython Classic, we don't have a good way of like putting work on a second core and like managing sharing a second core. Like we do a little bit of that with RP2350, but we kind of just say like, we're doing this on the second core, and that's it. That's all that's happening. But because Zephyr is actually a real-time operating system, we should be able to actually do a much better job of sharing work across cores. So for example, doing display I/O updates separate from the VM or separate from audio working, like we should be able to do some really cool things because we'll no longer be relying on our background task setup that we use kind of like for other CircuitPython. All right, well, that is an hour of deep dive. I don't see any final questions. Let's do a final check on here. So our builds are still running. A few of them already finished. Let's see what this says. All right, it added more tests, or no, it ran the advertising tests. So it included settings, it loaded settings, And then it removed the thing I told it to remove. Okay, so it's claiming that it's working. So I will do some more tests after the stream, and maybe I'll push it if it looks reasonable. And I will make sure that I do have to check that, like, oh, you changed the test or you fixed it, but like, do I trust you to actually run the test correctly? Not necessarily. I've had to, oh, I wrote tests, and you like run the test against the code, and it's like, it doesn't work. But yeah, okay. This has been another Deep Dive with Scott. It should be around next week, or for Deep Dive, although I'm out most of the start of the week. I'm going camping. Thank you all for hanging out. I hope you're excited about Zephyr as I am, and this new LM20. You can follow along on the Discord server by going to the URL adafru.it/discord. You can support me, and you can support Adafruit by purchasing hardware from adafruit.com or some of our resellers, or any of our resellers, because Adafruit still makes money off that. And yeah, thanks to Silvio from Espressif for helping me with getting the Espressif board build going. And Zephyr for doing some awesome work, and I'm excited for it. Thanks you all. I will leave you with the window. It's a smoky day here in Seattle. I was hoping the smoke would be gone by now, but it's lingered. So yeah, hope nobody else has too much smoke. All right, have a great weekend, everybody. I'll see you next week.